All right, so let's continue our data camp with the notebook alternative session. We have a vast majority of speakers with us today, and they're very excited to share more about this tool, Databricks, that is currently being evaluated. Just as a reminder, put your questions in the chat. We'll answer them during the Q&A portion. So at this point, I'm going to hand it over to Philip. He's going to kick things off for us from the eSimplicity perspective. We also have, again, folks from the Databricks team with us, as well as some of our CMS data scientists that were involved with the pilot. So we're very excited to have them on here today. But Philip, I'll hand things over to you.
Excellent. Thanks, Rachel. And thank you, everyone, for joining today's session. On the agenda today, we'll first touch on the use of CDR and talking by highlighting some of the metrics of its utilization and of its scale. From there, we'll talk about the background and the motivation as to why we pursued this particular pilot, and then introduce the two options and alternatives as part of that pilot, including Databricks and SageMaker. Next, we'll talk about the setup of the pilot, addressing its methodology and highlighting how we evaluated the two platforms. And then that will lead into talking about some of the highlights from the pilot results before we move on to a summary. You'll also get an opportunity to hear from the pilot testers that were part of this engagement for them to speak to the experiences that they had before moving on to hearing from the Databricks team and getting a demo of the product before ending with Q&A. So this following slide touches on the scale and the utilization of CDR, but today we host over 3,600 CDR databases, which translates to over 85,000 CDR tables. And that maps to almost a petabyte of data across CDR and SAS. Within this platform, we're running over 91,000 CDR and CAT jobs on a monthly basis, and that's supported by over 260 SAS workbenches used by over 1,700 CDR users. So in the next slide, with that amount of scale, we want to talk about what challenges people are facing today with the current platform and why we are thinking about alternatives to the technology stack that we have in place. First off, users do not currently have a stable non-SAS solution. For folks who have been working within the platform, that solution today is Zeppelin, which can be problematic and inconsistent in being able to run jobs and produce results. In the current environment, users also do not have access to specific programming languages, such as R, for their development. And within the current CDR platform, it is a static cluster that exists today to support your workload, but does not scale with increased user workloads, nor is it elastic in nature to be able to scale down when there are periods of low activity. And with this shared cluster that we have today, a lot of times users run into resource contention that it does not support personal compute. And finally, and perhaps more importantly, the current technology stack needs modernization. And so a part of this pilot is to be able to assess alternative solutions to provide all of you access to more advanced analytics capabilities to work more effectively and productively. So introducing the two solutions that we had assessed as part of this pilot. The first is Databricks, Notebooks and Compute. And providing a little bit of background on Databricks is that their notebook solution offers collaborative, interactive experiences across multiple languages, including R, Python. And within these notebooks, it supports real-time co-authoring and automated versioning, as well as giving users access to other ML features, including AutoML and its capabilities. One of the highlights of this platform is that they support the lakehouse philosophy and technology, where within a unified lakehouse product, it delivers the reliability and scalability of data warehouses with the support for data lakes and the inclusion of auto-scaling capabilities. Next, we assess SageMaker Studio. SageMaker Studio is a web-based UI product that's powered essentially by Jupyter Notebooks, fully managed within the AWS cloud. And it supports features such as AutoML, model building pipelines, and experimentation. And the underlying compute cluster and system behind this is powered by EMR, which supports the data lake architecture to be able to process large data sets and It also has the capability of auto scaling to all of your workload needs, fully managed by AWS. And the way that we evaluated both products was to look at both platforms from the lens from a user with user acceptance criteria, as well as looking from the engineering perspective of how both platforms could be managed and administered. And so from the user perspective within UAT, we looked at a couple of different areas, the first of which is UI navigation responsiveness. Between both Databricks and SageMaker, both were above average, where the UIs were both intuitive and responsive, and the workspaces around the notebooks worked well together in a collaborative nature. The second area was around built-in tooling and visualization. This is where we saw some differentiation between Databricks and SageMaker, where within Databricks, a lot of the built-in visualization, data profiling tools were good, along with matplotlib visualizations in line being useful. And on the SageMaker side, we had access to the generic Jupyter Notebook visualizations that came out of the box. As far as capabilities go, both platforms were average, where each platform provided a mechanism to be able to share notebooks, and both supported the ability for users to publish data as it pertains to the data publishing framework that we've spoken about in the past in communication calls. Next, we looked at training documentation. How easy would it be for someone to onboard onto the platform and learn how to use the product? Both platforms provide excellent documentation, as well as provided users above average machine learning capabilities. Moving on to the next area is around engineering validation. And within this particular section, we evaluated a lot of areas as part of that criteria. But what I'm showing here is essentially just going to be the performance testing as the takeaway. So if you move forward a few slides, move forward 2 slides, please. Actually, if you can go back to the engineering validation slide, I think there's a little bit of a delay. 1 more slide. Okay. So for the performance and scalability that we evaluated as part of the engineering validation, we saw a difference between platform performances in Databricks, where within Databricks, across the queries that we were executing, query runtimes were performing about 47% faster than SageMaker. And then in the following slide, provides a little bit more detail about how we assess the performance, in which we collected 12 representative queries that we saw running within CDR, where we ensured that there were queries that fell within small, medium, and large buckets around both complexity and also runtime. And what you see here in this stacked column graph are those particular query times stacked against each other to run each query individually, but also in total, the amount of runtime it took to execute the notebook. And in this particular experiment, we ran them on similar cluster configurations, controlling how the clusters would scale with the auto-managed scaling, as well as setting a limit to the max number of nodes that it could essentially scale to. And what you see here is the difference between the runtimes, where within Databricks for a notebook that ran these 12 queries resulted in 56 minutes versus in SageMaker was 1 hour and 49 minutes, resulting in that 48% reduction. So to summarize, a few of the highlights that I've touched on so far, Databricks and SageMaker provides similar user experiences with above average assessment and far greater functionality than the current solution for notebooks in which we have Zeppelin 4 today, in order to improve development productivity. Databricks runtime performance is greater than SageMaker by about 48% on average. Okay. At this point, I want to turn it over to a few of the pilot testers that were involved in this assessment to share their experiences.
Noah, I see that you're on. Would you like to start with your assessment from the pilot?
Sure. Can you hear me okay?
I can.
Yeah, so I absolutely loved Databricks. I thought it was a great tool in terms of speed compared to the other tools that we have, like Sassavaya or Zeppelin. It really blew them out of the water. One example I'll give is I was working on a project to sort of go through every table in the schema. And, this is something that Zeppelin couldn't even do. It would run for 24 hours and then crash, timeout. It was causing problems for other users using Zeppelin. In Databricks, it took me about 3.5 minutes. So just the functionality was great. I found the user interface just really easy to use, really familiar. There were more tools. I thought that was really nice. It had a couple other sort of nifty functions for easy exporting outputs to Excel. There were sort of on the cloud data visualization tools that I found very useful for sort of just experimenting with stuff. And I think one of the other great tools that it had was not only can you do your coding, but you can sort of use a studio view and browse through all of the tables within any schema that you have access to on CMS Federal. So I found it really great for just exploratory stuff to work with, just looking up variable types, so on and so forth. So I can't say enough good things about how much I liked it and how much of an improvement I felt that it was over the existing tools. SageMaker had some of those same advantages, but I just found it personally a lot harder to use, a lot more lag, and sort of a much steeper learning curve.
Great. Thank you,
And I
Noah.
would say one other thing which was nice is it took some tweaks, but for data users here who have been working in Zeppelin and have their Python code, you can basically copy it all over, and you might have to make some changes to use PySpark, but overall, I thought it was easy to not lose a lot of my existing work.
Well, thank you, Noah. We appreciate it. At this point, I'll hand it over to Andrew. Andrew, I knew you had some thoughts that you wanted to share as well.
Sure. Hello. Thanks for the opportunity to speak one of several times. I largely agree with what Noah said, and I think the presentation definitely, highlighted the key functional aspects of Databricks and SageMaker, and especially in relation to, the hurdles that we had with Zeppelin or having to rely on SassVia, for a lot of newer programmers who, want to work in open source languages and, sort of take advantage of the open source community. I also think that it taught us a lot about making data access or making data available via the platform, and, how adapting the ways that people work in SassVia to, these new platforms could be done, and, probably needs some planning around transitioning to some degree. And it will also inform how I think we, perform data analysis. The other thing that's nice about Databricks is it leverages Git, and we're increasingly, sort of expecting and also putting code on Git to learn from. Something that I'll expound on later is sort of the development of institutional knowledge. And I think Databricks, in having Scala, R, Python, SQL all be available in those notebooks, and then the Git versioning piece, we're going to be able to really take advantage of that and sort of especially leverage that towards the idea of data as a product. And for people who don't know what that is, it's seeing the development of tables as a both contributor to a learning process, building that institutional knowledge, but also having the output of analysis, basically the tables that maybe are the focal points of charts or plots or particular high level percentages or things that are being highlighted, metrics, as reusable pieces of or data sets. And so I think this will enable that as well. I was able to take advantage of the fact that DBT works sort of as an extension. DBT is basically a pipeline generating software. I mean, that's probably not the best way to put it, but it offers a way of visualizing transformations. You can, much like Airflow or Jenkins, create pipelines and then work on continuous improvement and continuous development. Should that be something. There was one other piece that I wanted to highlight in relation to that. Oh, one of the nice things that I did notice about this, you're able to annotate and sort of develop table documentation as you go, or maybe for, the last table that you make, like I did. And when you add descriptions via the sort of accompanying YAML files that go along with basically SQL scripts that sort of form your pipeline, in the comments of the data lookup that is available through Databricks, you can see the descriptions. So all that work that someone might have done to provide descriptions on like what the columns are is going to be useful to someone in the Databricks platform. So that was nice to learn. And so, I think this is always going to be part of an evolving solution. I think these are great steps towards, leveraging the information we have and maybe changing the way that we collaborate. So thanks for letting me ramble on.
Absolutely. Well, thank you both for your feedback. So at this point, we're going to hand it over to the Databricks team, who's going to be showing a demo and more information about the Databricks application. So Databricks team, I'll hand it over to you at this point.
Thank you, Rachel. And I think my colleague, Adam Kingsdorf, will actually be taking the lead and walking us through the demo.
Thanks, Reef. Hey, everybody. I was just arranging my monitors. Let me share my screen and we can go ahead and get started. Can you guys see my screen?
Yes, we can.
All right. Put this in presentation mode. All right, and let's get started. So, hey, everybody. If we haven't met before, my name's Adam Kingsdorf. I'm a senior customer success engineer here at Databricks. I've been covering CMS actually the last 3+ years, so maybe you've seen me before at other accounts if you guys have been around. Today, I'm going to talk about briefly first what Databricks is as a product, who our founders were, what their mission was, what are the problems we're trying to solve. And then I'm going to do a demo of some capabilities in the UI. I know I'm on a pretty tight time crunch here, so I think we're going to save questions to the end. So let me give a quick overview of what we're going to go over, right? I think I mentioned a couple of these, what Databricks is, our homepage, right? We're going to do a demo of workspaces, how to access data options, connecting to clusters, notebooks, managing jobs, and then I'll do a quick demo of Databricks SQL as well. So what is Databricks? So Databricks is a unified analytics platform that allows data scientists, data engineers, and business analysts to collaborate to solve some of the world's toughest problems. By using our platform, we allow organizations to drive key insights from their data, and we'll be diving into more detail about the components of Databricks platform on subsequent slides. But who are we, right? So Databricks was actually founded by the original creators of Apache Spark all the way back in 2013. And we still contribute 75+% of the open source code to the Apache Spark product and repo, which is 10 times more than any other company. So we've trained over 100,000 users, probably over 1 million at this point, across thousands of organizations on the Databricks platform. So in the case of this large financial institution, right, they had a lot of challenges. They had a lot of new data, but they also wanted to implement some new features, such as fraud detection. And they ran across challenges that a lot of us have come across ourselves. They wanted to unify the data engineer, the business, and the data scientist in an environment where they could all collaborate. So they could choose the languages they wanted to use, the libraries that they wanted to install, et cetera. Not only that, they could come together into this one product, into this one platform to produce a product. And specifically utilizing big data comes with its own challenges. And then driving AI or ML on top of that data increases the complexity even further. So a lot of those challenges we can really categorize into these different groups, right? So the manual operations or O&M cost to manage this infrastructure was resource intensive, complex, and time consuming. Next, there were issues with data pipelines on top of this infrastructure. So organizations are facing numerous problems to produce quality data. Challenges arose with providing new data and avoiding stale data, and performance was so slow it was difficult to get real-time data to stakeholders who needed it. And there was also a huge array of these different tools and languages. So that increased complexity further, which then in turn slowed innovation. And lastly, there was little or no collaboration between these different user groups. Data engineers, data scientists, and business analysts, they all operated within their own tools and silos. So what we originally built here at Databricks is a unified data analytics platform. So I'm actually going to talk about what we've expanded upon since this on the next slide. But from a high level, what we originally built, it was essentially separated into 3 layers, right? You had this first or bottom layer, which was the Databricks Cloud Service. So right now we actually support Azure and Google Cloud as well as AWS. I know CMS is AWS shop, and I believe you guys are AWS as well. But essentially, regardless of that, Databricks was designed to be cloud native, take advantage of the benefits of cloud, such as scalability and elasticity. And in the middle layer, right, we built this Databricks runtime, or the engine behind our product. So Databricks supports many machine learning frameworks such as RStudio or TensorFlow. We also support an open source file format we invented called Delta, which brings performance and reliability benefits to your data lake. And on top of this, users can leverage all these benefits in the Databricks workspace. And the workspace is comprised of APIs, jobs, notebooks, models, and dashboards. And Databricks also developed MLflow, which helps organizations build, test, and deploy machine learning models into production. And with E2 that we just became FedRAMP authorized on, we really have expanded upon this, right? So new features include Databricks SQL, which expands on our BI user capabilities, Delta Live Tables, which makes it easy to build and manage reliable data streams or pipelines that deliver high quality data, and AutoML, which is a glass box approach that allows you to quickly generate baseline models and notebooks. So we're going to dive into this workspace today. We're going to talk about scheduling fast, reliable jobs, analyzing data with notebooks built in SQL, R, Scala, and Python, building dashboards, creating interactive reports of your data. And we're going to cover all this in the demo today. So with that, I think we're ready for the demo. So I'm just going to go ahead and jump in. So I want to make sure we can cover everything. So this is the Databricks homepage. This is just it out of my Databricks environment, right? So this is not out of the CMS environment, but if you have an E2 shard, it should look pretty similar to this. I'll just quickly talk about the homepage. So essentially, we've created different lenses for different user personas, right? We have the data science and engineering. So this was the traditional notebook. If you used our private cloud deployment, this was the only, back in the day, this was the only option available to you. And you would just have these notebooks, right, which are similar to Jupyter notebooks and things like that. And this was mainly where you did your development. On top of that, what we've done now is we've carved out the machine learning component of this to make it easier to create experiments or access the feature store and things like that and track your models, right? So we have this other part of the UI, mainly for data scientists, for people doing machine learning. And then I'm also going to cover Databricks SQL UI today. But essentially, there's a query editor. You can create dashboards of queries and visualizations and things like that. So I just wanted to give you a 10,000 foot overview before I started diving in. So essentially, like I said, we have these different lenses for these different user personas. Like we mentioned earlier, right? Databricks is really meant to have different user types all collaborate in one product with their different use cases and their data. It's really just meant to foster collaboration, right? You can use what languages you want and things like that. All right, so with that, I'm going to jump into data, right? So obviously, it's the data analysis tool. So you need your data into Databricks. How do you get your data into Databricks, right? So I'm quickly going to touch on this data explorer. So I was talking to Arif and Tim from my team, and they mentioned we're not quite sure if we're diving into Unity Catalog yet, which is fine. I just kind of wanted to show you what this looks like today. So essentially, you have catalogs, which are an abstraction on top of your metastores, your Hive metastore, right? But if I click into this Hive metastore, this is basically where your data would be stored. Your data is typically stored unless you moved over to Unity Catalog. And you can see these different databases in here, and each database has numerous tables and things like that. So if you click the default database, you can see that some of the tables that are created, these are some of our mock demoing data sets in here, like airline data and Airbnb data and things like that. I think there's a diamonds data set in here too, and that's the one I'm going to be demoing with today. Cool. Yeah, you can see that here. So if I click this in the Data Explorer, you can see, which is really cool, you can see a sample schema of that data that we're going to be playing with, just to show you how this works. You can see some sample data, some details on it, permissions, history, things like that, right? And then let's see here. Okay, adding data, right? So this is assuming that data is already accessible, but what if your data is not already in Databricks? How do you get it in here? Well, we've created this add button, right? So if you click add and then you hit add data, you can see here that there's multiple different ways to bring your data into Databricks, right? You could, if your file's small enough to store on your computer, you can just upload it, kind of how you would upload a file to an email somewhere, right? You can drag and drop it here, or you can browse it, and just hit open, right? And then that would create a table of your data, Databricks. You can also bring in your data from S3. You can create a table in the UI. One thing that's really cool though is if you hit create table in Notebook, you get like a template for how to bring in that data from that data source. It's basically like a quick start where you just fill in the blanks, right? So here you can see file location and type, file type, CSV options, things like that. And then you would just have to insert the values here for these, blanks, and you would be able to read that data from S3. And sometimes if you have like an Oracle database and things like that, you might want to connect to an external Oracle database and then pull in that data. So you would just fill in the blanks like here. But the whole idea is we allow you to have like these quick start notebooks to pull in your data from wherever you want, just to make life easier on our users. Okay, I'm just going to go back to data.
Hey, Adam. Yeah, quick question. Is there any way for you to make your screen a little bit bigger? Some folks are having difficulty seeing
Yeah, let me see. Is that better?
Yes, thank you very much.
Sure. Yeah, sorry. I actually asked people to help monitor the chat for me because I want to try to get through everything. So hopefully, yeah, I just zoomed in. Cool. All right. So if I go back to data, was there anything else? Adding data, I think. Oh, maybe I'll show the DBFS real quick. And you can see we're expanding our partner network as well. Looks like there's 5 trained data sources available here now. So we're constantly, just expanding our data source partners and connectors and making it easier to bring in data. So essentially, we believe in open source here at Databricks. So wherever your data lives, we want you to bring it into Databricks. If you want to pump it back out to other tools and applications, you can do that as well. It's really meant to be open and collaborative, even beyond just our tool, which is a really, really cool thing. And then real quick, I'll just show you if I wanted to browse. So back into the Data Explorer view now. We also have something called the Databricks file system. So this is where folders and files of different files basically live on top of your storage system. For Amazon, that'd be like S3, right? So this is basically your file system for Databricks, and you can see certain files that are in here and things like that. Navigate similarly like you would in a regular, file system on a Windows or Mac computer locally. So we designed it to be pretty similar, right? And you can upload files to the Databricks file system. All right, so here we go. And let's go. I think maybe we'll go to the notebook portion of this demo now. So you can see here, how do I get to notebooks, right? So we have this cool thing called a workspace, right? It looks kind of similar to the DBFS or the Databricks file system. But essentially what this does, and I'll zoom out a little bit here so you can see like a higher level overview. We have a shared workspace. So maybe if you had projects and things like that, you could create folders and files and things like that. So typically, like I usually tell people, if you have like projects that are collaborative, usually you want to create those in your personal user workspace, because that's really private, but you could share things from there. But typically I recommend using the shared workspace for projects, or you could just use the basically the home workspace over here, right? Just want to give you an idea of how this works before I quickly jump into a notebook. And you can see in here, I can create like notebooks and things like that. So if I wanted to, I could create a notebook called like test. And you can see here, there's like 4 different default languages for notebooks. Now, the cool thing about Databricks, and I'll show you this in the demo, is you can have multiple languages within a notebook, and you can change your default language after you've created it. So it makes it really easy to go back and forth. If you're creating a notebook, you see this cluster option here. You'll want to click a green checkmark cluster. I think everybody here won't be creating their own clusters. I was told you're going to be leveraging ones that have been created for you. So you'll want to make sure that whatever notebook you have, you attach it to a cluster, the green check mark. That means it's on. So if I do that and I hit create, I have my first notebook, right? And then you can see here it's within that project folder. Now, what's cool about this too, and why I recommended, creating project folders outside of your user workspace, is you can share individual files and folders. So if I click permissions of this file, you can see I can share this with like a group of users. Like I like cool kids, why not? Can run permissions, add, and then I would hit save, right? But you can see here there's different permission sets, right? And we actually talk about what these mean in layman's terms, just to make life easier for you, because you have can manage, can edit, can run, and can read permissions, right? And I'm not going to get into all those now, just know that those exist. And you can actually add permissions for individual users as well, and things like that. And you can hit add, and then you would just hit save. Now, similarly, you can do the same thing on the project folder level. So maybe if you had like project managers, you'd give them access to everything and give them access to the whole folder. And then maybe you give users only access to individual code notebooks. Up to you how you manage it. I just wanted to let you know that permissions kind of works the same way for both. It's up to you how you manage it. We also have service principals as well. I'm not going to get into all that. I think some of the permissions and tokens and things like that are still being worked out here on how that's all going to work. So I'm not going to really dive into permissions too much. You can import and export notebooks too. So if I wanted to, if you had multiple Databricks environments, right, maybe you wanted to download this file and just put it in a production environment, right? You can hit export. You can right click the notebook, hit export, and then hit archive or source file and things like that, right? And then you can just import it in a similar way. You just hit right click, import, and then you would just drag that file that you downloaded here, or you would just search for it, right? And then you would just upload. So we do allow for importing and exporting of notebooks too. All right, I just wanted to give a quick overview of kind of what that was, because it's important to know what the workspace is and how to navigate in it. But let's dive into the demo now. So you can see here, Adam Kingsdorf, I went to my user area, and this is my private workspace. And you can see all the files and folders in here. It's quite a mess. I have this nice pre-created rapid start template for you here. And you can see here, like I mentioned earlier, the default language for the notebook is kind of listed up here at the top. But if I click this, like some other options here at the top, I mentioned clusters, right? So maybe you already have a notebook that's created you can come in here and you can see what clusters you have access to and the active resources. They'll have the green dot, right? And I connected mine to a cluster that's on. So I'll be able to run this code. So I pre-run everything to save time, but just know that because this notebook is connected to a cluster with a green dot and it's connected and running, that I'll be able to run code, right? So if I go to this first command, right, I mentioned you can run other coding languages that's different than the default language within the notebook. So you can see here that I have Markdown, and you can do this by using what we call magic commands. So anytime you have a percentage sign and then you put some text after it, there's certain magic commands that you can do within Databricks. And I'm going to show you those in this notebook. So you have a Markdown command that you can do, and I'm basically importing this image from this URL and setting this kind of header format. And you can see here that I've created this header. And you can create other types of headers too, right? So if you've done markdowns and like a readme.md file for Git, if you're familiar with Git, it works kind of similar, that type of syntax, right? So I can do that as well. So here I actually created the title for this cell. And then I'm running this code from the file system. I'm listing out this path, and you can see some of these files that are available to you. So it's pretty nice to do data exploration and like navigate the file system. Databricks tries to make it easy to do all those things, right? You do have the UI as well, like I mentioned, but you can navigate via the notebook commands as well. So this is a file system command because I have this %fs here. You can see some of these CSV files, some of the sizes of these files, the modification time, et cetera. And you can see this diamond CSV file that I mentioned earlier, the one that we're going to demo with today, just for exploratory purposes. You can do shell commands in Databricks as well, and you can see some of the options here if I just run an ls command. It's Linux under the hood if you didn't know. I just wanted to point that out. And then Python, right? So I actually don't need to do this, but let's say I changed, if I knew I was going to change the language of this notebook to SQL or something like that, this Python code would always run because I have their magic command with Python in front of it. And here, this is basically just another way of doing the DB utilities file system list command. It's actually technically the same command as the %fs ls, right? But you can see how the output changes a little bit differently when I call this natively from this Python function as opposed to just the file system command. So it gives you the same output, just in a different format, basically. I did want to point out, you can see like an editing history. So if you use Microsoft Word or Google Docs and things like that, the version history looks very similarly, and you would just click one of these to revert back to a different version history. You can also delete version histories if you want, or if something were to break, it allows you to revert back, and it also tells you what user would modify the notebook at what timestamp. So super, super helpful. I'm not going to go too much into that, but I just wanted to point that out. And then you could add comments and things like that if you wanted to as well. And then maybe I'll just keep going here. I'll talk about maybe at the end of this, scheduling this to run. Essentially, you can run these cells, by the way. You can run all of them, or you could do like a shift enter command, and you can click here and you can run a particular cell. So it's up to you what cells you want to run and things like that. You can also do like a run all above or run all below. There's minimizing cells that you can do. So each one of these blocks we call commands or cells, by the way. And then if you hit this X, you can actually delete them. So it's flexible. If you want to move things around, you can do that. I think it talks about it here under edit, but you can move cells around if you want to move them up and down. You don't want to delete things, you can do that, but you can delete things as well. So there's really there's a lot of options for really whatever you want to do, right? And there's a lot of keyboard shortcuts as well. So if you're a big shortcut person, I haven't memorized all these, but there's a ton of them. So that can save you some time too if you're working on these notebooks.